Unit 3, Activity 3, the vertex and applications of quadratic functions. In the first two activities, we have found the maximum or the minimum points of quadratic functions using the calculation capabilities of our graphing calculators. In this activity, you will learn how to find the vertex using the symmetry of a parabola, and you will develop a formula to finding the vertex. In addition, this activity will practice answering more general questions using quadratic models. For example, when does a falling object reach its specified height? If profits rise and fall based on the amount spent on advertising, how much should a company spend on advertising to make a specified profit or to maximize profit? Learning outcomes, you will explain your reasoning and in obtaining estimates or solutions using quadratic models. You will also demonstrate the use of a general problem-solving process. You will use tables, graphs, and technology with Desmos and symbolic models to solve problems and find solutions for quadratic functions in applied scenarios. Let's start with some skill review problems. The first one, use substitution to solve for x and y in the following systems of equations. 3x minus 7y equals 20 and y equals 2x minus 6. So as you can see here, the second equation, we have a value of y which is equal to 2x minus 6. We're going to use that to substitute to the first equation. So the first one, 3x minus 7, we're going to substitute the value of y here, which is 2x minus 6 is equal to 20. And then now we'll solve this. So let's distribute negative 7. So that becomes 3x. Negative 7 times 2x is negative 14x. Negative 7 times negative 6 is 42 equals 20. Then let's simplify this. 3x minus 14x is negative 11x plus 42 is equal to 20. Then we subtract 42 both sides. So negative 11x is equal to 20 minus 42, negative 22. Then divide both sides by negative 11. So that our x is equal to 2. And remember, we need to solve for x and y. Now we can substitute this to the second equation, either the first or the second, but let's use the second equation. Y is equal to 2 times x minus 6. Our x now is equal to 2. So 2 times 2 is equal to 4 minus 6, and 4 minus 6 is negative 2. So our solution set here is 2 and negative 2. Okay. Then number 2. Solve 4 times 1.08 raised to x is equal to negative x squared plus 3x plus 10 using the graphing utility on your technology and document your steps. Remember, we did this in the last activity. We have two equations here, and we can graph this. First, the left side, which is 4 times 1.08x, and the second, y is equal to negative x squared plus 3x plus 10. And the first equation, this is an exponential, and the second is quadratic. Now let's use Desmos for this. So this is Desmos. I typed the two equations. The first one, 4 times 1.08 raised to x, and the second, y equals negative x squared plus 3x plus 10. and we want to find the solutions, and those are the intersections. And we, as you can see here, the graph, the red one, that is the exponential, the red, and the blue is the quadratic, which is the parabola, and we want the solution, which are the points of intersection. So we have here negative 1.445 and 3.579, the other point 4.101 and 5.484. And we use decimals to get the points of intersection, and this is a rough sketch of those two functions. So that is our answer. Now let's proceed to our class discussion. Consider the quadratic function f of x equal to x squared minus 3x minus 6.75 as shown to the right. And we want to find the x-intercepts of this graph. Use either your technology or the quadratic formula. X-intercepts meaning those are the points on the x-axis, and these are the points on the x-axis. And using decimals, you type the equation x squared minus 3x minus 6.75, and our x-intercepts the points on the x-axis. You'll see here that's the first point negative 1.50 and the second point 4.50. Now let's go back to our notes. So the x-intercepts, the first one here, that's negative 1.50, and the other one 4.50. Okay, so we know that this is your x and y, these are the coordinates, and we're going to use the x values and find, for letter B, find the average of the two x values. Let's do that. So the average of the two x values that is negative 1.5 plus 4.5 divided by 2. Negative 1.5 plus 4.5 is 3 divided by 2, and that is equal to 1.5. Then, letter C, substitute the average x value you found in part B into the original equation f of x equal to x squared minus 3x minus 6.75 to find the corresponding y value. Let's do that. So here, y is equal to 1.5 squared minus 3 times 1.5 minus 6.75. 1.5 squared is 2.25, and 3 times 1.5 is negative 4.5 minus 6.75. And this is equal to 9. Okay, then use your technology to verify the x value and the y value from B and C, and those are the coordinates of the vertex of the graph. So vertex, the x coordinate is 1.5 and the y coordinate is 9. So let's use decimals. So we have our graph here. the parabola, and this is the vertex with 1.5 and -9. So that is correct. This demonstrates that the vertex of a quadratic function is precisely in the middle of the two x-intercepts with corresponding y value determined by the given equation. Alright, next number. For any quadratic equation ax squared plus bx plus c is equal to 0, we can use the quadratic formula to find the two x-intercepts. According to that formula, the two solutions are -b plus square root of b squared minus 4ac over 2a and -b minus square root of b squared minus 4ac over 2a. Now let's do this. Average these two x-intercepts together to find where the vertex is located. So let's take the average of these two. So -b plus square root of b squared minus 4ac over 2a plus -b minus square root of b squared minus 4ac over 2a all over 2. Since they have the same denominator of 2a, so we can add the numerator. So -b plus square root of b squared minus 4ac plus -b minus square root of b squared minus 4ac, and this is divided by 2, that is 2 over 1, so get the reciprocal of that, that is times 1/2. And here you can see that you can cross out square root of b squared minus 4ac minus square root of b squared minus 4ac, so that's 0. So this is equal to -b minus b is -2b over 2a times 2 is 4a, and we can still simplify this. They're both divisible by 2, so that is -b over 2a. So now we can see that the x value of the vertex of quadratic equation is -b over 2a. Okay. Then the corresponding y value is found by substituting the x value into the given equation. Okay, next one. The profit function for a small business is x is equal to -4.1x squared plus 147.15x minus 567, where x is the number of units of product produced and sold. The question now is, how many units should business aim to sell in order to maximize their profits? What will that profit be? And use the formula we just found in question number 2 to answer this equation, and then use technology's graphing utility to check. So we found out with our equation that x is equal to -b over 2a. So based on the given function f of x, I'm going to rewrite it here. Y is equal to -4.1 x squared plus 147.15 x minus 567. We can identify our a, b, and c. A is -4.1, b is equal to 147.15, and c is equal to -567. So let's solve for our x. So substitute your b, which is 147.15 over this is negative 2 times a negative 4.1, and we simplify this, use your calculator, and it's approximately equal to 17.95. And to find y, we substitute the value of x. And when we substituted the value of x to the given function, so y equals negative 4.1 times 17.945 squared plus 147.15 times 17.945 minus 567, we get our value of y 753.312. So you can say that that point of intersection is at 17.945 and 753.312. And let's check using Desmos. So here we type the equation and let's zoom out to find the point of intersection, or move this, and here you go. Here's the point of intersection. Just click on the top and you'll see that it is 17.945 and 73.312. Okay. X value, that's the unit street business aim to sell in order to maximize their profit. That is, we can say that is approximately 18 units. This is our profit, 753.312. Okay, and that's it for this section. And let me know if you have any questions. Thank you.